helping new parents, like parents with small children. Like a lot of her videos, I don't follow her or anything. It just showed up in my, the reels or whatever it's called. You're just scrolling through and it's like, oh, that's good, like a monster truck or something. But anyway, so I have two grandsons and a third on the way now. I don't know if it's a son or not, but and so I think that's why I keep getting this stuff about newborns and raising children. It's not me raising them; it's my children that are raising children. But anyway, getting back to this, so we have quantitative variables, we have pairs of data, we have scatter plots, and so here, I don't know, I've got it on two different devices to figure out which one I want to use. We'll use this one. Okay, so let's show you some scatter plots. This is not your class, obviously, because those are final exams there. This is another class a couple of semesters ago. I took homework grade and I took final exam score. Now, despite the fact that correlation and causation are not the same thing, I think that we could probably presume that there is a little bit of a causal link, I don't know, between these two. So take this with a grain of salt. So notice that on this graph, I have a couple of semesters ago the grades, and the students who got hundreds or close to 100 on their homework grade got, well, they passed the final exam. So I would have liked it if they were all way up here, but generally, students who did their homework did better on the final exam, and those students who didn't do their homework did less well on the final exam. So there's a relationship, there's a causal relationship. It almost looks like someone took a shotgun and just shot the screen here, and you have all the pellets go that way. This is the way a lot of scatter plots look. And because there's randomness that's introduced into the data, so it all spreads out, but there's a general trend that you see, so that things go up. So we want to be able to compute what is that general trend. Here. I should mention where this next slide comes from. So a few years back, I made the mistake on that first, you remember that survey that I gave you? There was a question, I think I had a question on yours about what year was Martin Luther King Jr. assassinated. I don't know if I had that or not, but it was 1968. And so I had that on the survey at the beginning of class a few years back, but I made a mistake and I copied it. And I don't know how, but I had one question that asked, when was Martin Luther King Jr. assassinated and what year did he die? So I had those two questions. And so you can imagine that there's probably a pretty strong correlation between the answers to those two questions. And so here's the scatter plot. And I know, you can imagine some kid that doesn't know what these words mean, perhaps, and they think that assassinated, I don't know, means something different. And so you have this person here who, Martin Luther King Jr. died in 1942, but was assassinated in 1940. Maybe they were shot. Maybe assassinated means when they were shot. Then they held on, like Martin Luther King Jr. was in the hospital for a couple of years and then finally passed away. So anyone below the graph, that's below the line, that's what they must have thought, maybe, is that assassinate is when you get shot and then whatever. And then these people think that Martin Luther King Jr. died in, say, 1950. That's when Martin Luther King Jr. died, but then Martin Luther King Jr., he was assassinated in 1972. So maybe they were confused about what that word means. Maybe they thought assassinated means something about, I don't know, venerated or, I don't know, became a saint or something like that. So, I hope that I get to be assassinated after I die as well. But anyway, there's this weird thing. But the cool thing, at first I was kind of embarrassed that I did this. And then I thought, and after I started making fun of kids, after I got done with that, I thought this is really cool though, because there's a really strong correlation here. So certainly there's a few random people here and here, but most of and I believe that this was a year that I gave this survey to all of my classes, so you can't see it here, but there are a whole bunch of people that are on top of one another here. And so this was a super strong correlation. Only a few, and those are these dots here and here, thought that, we're off of the line, but almost everyone else is on a straight line. So this shotgun, if you shot this, it's much more focused, is where all of the little pellets went. They're all focused in the middle here. So when everything's focused, that is a strong correlation right down the middle. And when things are spread out, it's not so focused. Okay, let's see what's next. Okay, here's some correlations. I actually looked up this a few years ago. I'm too lazy this year to do it again, but a few years ago I was like, okay, let's find some correlations. So I went to the literature, went to the library, and I just was searching for correlations in various research journals. So education and income, this is something that was written about a few years back in education, that the more education, the more income in general. That doesn't mean that you're not going to find a PhD who's a bum. I know my brother has a master's degree and he's not doing well at all. And you won't find, and it doesn't mean that you're not going to find someone who has a 6th grade education who's a millionaire. But in general, there's a relationship, a correlation. Does one cause the other? I don't know. Height and weight. There again, height and weight. The taller you are, the more you weigh. Found this in the literature. From a finance journal, age and net worth. In general, the older you are, the more money you have. I'm shopping for a house, and my son-in-law and daughter, who make way more than me, are like, we're struggling. We don't know if we can afford a house. And I'm thinking, you're making more than double what I'm making. Anyway, but it's because we have more cash on hand, I guess, because we've lived longer, and so we've just saved up. And so age and net worth, the older you are, the more usually, in general, once again, my brother would be a counterexample, but he had problems with drug use and so forth. Sodium and blood pressure, this is from a nursing journal, that the higher your sodium intake, the higher your blood pressure in general. That doesn't mean some people aren't going to be anomalies and be able to eat salt all they want, but in general. Negative correlations, and you can see here, education and years in jail. It means that the more education you have, the fewer years you're going to spend in jail during your lifetime. Generally. Not always true, but generally. Crying and being held. This isn't talking about your boyfriend or girlfriend. This is talking about babies. So generally babies, the more you hold a baby, the less they cry. I can attest to this. My second grandson, if he wasn't held, he would be crying. It was either one or the other. And so we held him for like 2 solid weeks when we were visiting, and then we were thankful when we got to get on the plane and go home. But anyway, we love him. Don't worry. He's doing great now, but at least when he was first born. TV viewing and grades, once again, from an education journal. Strong negative correlation. The more you view TV now, probably YouTube, Instagram, me doom scrolling on Instagram this weekend but I was just overjoyed to be able to find an Instagram influencer who was talking about correlation. But anyway, so TV viewing and grades, the more you watch screens, the lower your grades. And then potassium and blood pressure, so it's the opposite. It was the same study. So eat your bananas, your blood pressures will go down. Okay, so let's get a handle on what correlation means, and then we'll see what we're going to do with this. You have your shoe size. I mentioned this earlier. You know your shoe size and you know your height. Now, this is American shoe size. If you really want to use your European, I don't know how to help you. So, I mean, I know my European is like 48. I don't know. It's gotten bigger. It used to be 47, but now I'm much more comfortable in a 48. But anyway, shoe size and height. Here's what you want to do. And here I think I do have to switch over to this, because this will be a lot easier for me to write. Give me a sec. Now I can write. Okay, so pick your gender, and you're going to compute the z-score for your height and your shoe size. So I'll just do myself. I'm not ready to tell the truth. I'm just going to say I'm 73. I used to be 73 inches. I'm not anymore, really, but I'm not ready to let go of that. So 73 inches is what I'm going to pretend to be. Okay, so just to remind you, z-score, z is going to be 73, your height, minus the average for your population divided by the standard deviation. So if you're a female, go over there on the left, and you might notice that these numbers are a little different than they were last time we used them, but it's mainly just to make things easier on everybody, the calculations. So there it is. And then you're going to do the same thing. So this is 1.333. So do the same thing for your shoe size. So once again, Z, you take your shoe size, American shoe size, and this is American men's shoes, Americans women's shoe size, which I know if we were Europeans, we'd all be in the same boat together with those 40s, 42, 45, whatever. But Americans have to be hard, difficult, don't we? So anyway, there's this. So just how you do it. So go ahead and do your own. Take your height, your shoe size, get your z-scores, and then the second thing you do once you get your z-scores is you're going to multiply them together. So give me a minute. I got to do mine. Okay. Okay, so I've got mine, and each of you has yours, hopefully. I've got 1.67. Now, here's the interesting thing, is if we were to take all of ours and then average them together, we would get the correlation for height and shoe size. So that's what correlation is. It's just an average of this product of z-scores. So you take the data that you have, compute a bunch of z-scores, average them all together, and you get your correlation. Now, here's what's cool about this, though, is that if there is a positive correlation means that when your height gets bigger, your shoe size gets bigger, which that is the case. What that means is that generally, we will all have positive numbers down here. Positive correlation means these will be positive. Now think about what this means. This means that if your height is above average, your shoe size probably is above average too, and you'll have two positive numbers like I did to multiply together. If on the other hand, your height is below average, it's likely that your shoe size is below average as well, and you'll have two negative numbers to multiply together, which gives you a positive number, right? Now, here is the situation where you don't have to answer if you don't want to. But I'm curious if anyone wants to volunteer that they were in that situation where they had two negative numbers that they multiplied and got a positive. You did? All right, very good. So Kirsten is shorter than average, has smaller, more petite feet than average, which is what you would expect, right? It's not the height causing the shoe size or vice versa. It's the genetics, right? That are causing bones to grow longer or shorter, or have a. My mom always used to say, "Son, you've got big bones." And it's like, no, I'm fat. But anyway, you've probably heard this. If some of you have heard that, when you're the chubby kids. Yeah, I was one of them. But yeah, all right. Yes, your mom was commiserate you, large bone. But anyway, yeah, my bones were large. Yeah, also was fat, but my bones were large, which made my femur large, and it made my foot huge. So everything is bigger. And that was because of the genetics. It said bones grow big. And then some people have the. Now, what's really unusual, and this is really cool if you're in this category, is if when you multiply, you get a negative number. Some of you might have that situation. That would be either that you have a negative z-score for your height and a positive for your shoe size, or vice versa. Once again, you don't have to answer. But is anyone in that category where you have a Oh, nice, Sienna. Sienna, what are your numbers? Ooh, interesting. So you're taller than average, but have small feet. So so it's surprising that you're able to support yourself as you walk, but very nice. So it's a tall person with small feet is going to be in that boat. Is anyone the opposite? Have big feet and are short? Maybe no one wants to, because I was going to make fun of you, say you've got clown feet. Oh, no. You probably already got that. Actually, you probably did as a kid. I apologize. Oh, you're clown foot? Sorry. But anyway, if you have big feet and you're a short person, that's unusual. But most of us are in positive land, and if you average all of our positive numbers together, you're going to get the correlation coefficient. We call this thing the Pearson R, correlation coefficient. And I got to confess something, and that is that you're not going to have homework on this until, let's see, the homework due Wednesday doesn't have this on it, but I can't do what we're doing for Wednesday without at least mentioning this. So I'll show you what you're going to do for Wednesday momentarily. It's pretty basic. So I guess this will be for the following week. It's fine. We're a little out of order. So don't write these down. This is completely useless, but it's background. This is what we did. We did the z-score for one of our variables. We did the z-score for the other variable, and then the correlation coefficient, R. R is the correlation coefficient. It's the average of the products. That's the literal way that we do this. Now, that's really hard to compute, because to do this, you would have to compute z-scores, 2 z-scores for every data point. Takes forever. So an easier way is to do this. This is what I used to make kids do back in the old days when we had hand calculators. I'd say punch this in, which it's not as hard as it looks, but it was still kind of painful. And then the easiest way is to just use Excel. Let's take a brief, wait, do we want to do the interlude yet? Intermission? Yeah, let's do intermission real quick. So intermission, end of course surveys. I got a note this morning that end of course surveys were released today. And so you know the drill. Maybe if you're a freshman, then you don't, that they get mad at you if you don't do the end of course surveys. And I don't know, is there a notification on Moodle or something? There's an email. They don't notify. In the old days, yeah, maybe 5 years ago, they would shut down Moodle for you if you didn't do your end of course surveys. I know. So they don't do that anymore? No. Okay. Yeah, I remember they got some nasty emails. There were some angry students. But anyway, it's not that hard to do. You might be worried that you don't know what the answers are for the end of course survey, so I thought I'd help you out here. So anyway, there's the answers. Okay, so what we're doing today, if you go to Moodle, I don't know if all of this is here, but we're going to be looking at the linear regression. Now, you don't have to do this because what we're doing together is not quite as involved as some of the other days, like making the confidence interval gold website or anything like that. So it's not quite as involved as in the past, but it might be helpful to at least do a little bit of this. So if you want to, I'll give you a minute and you can grab that the one that says linear regression. It's on the Excel files tab. And it looks like this, at least the first tab looks like this. It says, what does it say? Example 1, subject, movies, math. I'll give you a minute if you want to get yourself set up. If you don't, you can just relax and do whatever you want. Okay, here we are. Oh, that's not what we want. Oh, just a minute. Sorry. Why did that do that? There we go. Give me a sec. I'm going to go grab the homework. But yeah, you just grab that file. There's some weird stuff with the homework that I need to make sure that you can see. There it is. Okay, good. Excellent. Okay. Okay, so if everyone who cares has this, I'll explain what this is. This is just some fictitious data that I made up just to illustrate what we're doing today. Where did it go? It's disappeared, hasn't it? There it is. So anyway, there's my fictitious data, and it is data that is supposedly, allegedly, number of movies watched per week and score on a standardized math test. So I just made up the numbers, so don't worry, it's not really true. But anyway, here's movies, here's math, and that's what that is. So what we're going to be interested in is two things with this. We want to be able to make a scatter plot. You know how to make a scatter plot because you've all been in 7th grade math where you had to put dots on a graph representing whatever it is that you're doing. We're going to do the same thing here. We have movies and math. Before we do this, though, I should need to mention a couple of things about how you make a scatter plot. And I know you think, oh, it's simple. You put a dot where you see the point, right? Yeah. But first off, we need to decide what is going to go along the horizontal axis and what's going to go on the vertical axis. So that's our first chore. So maybe I do need to go back to here. Here, let's go back to this slide so that we have something to write on. So we're going to make a scatter plot. Here we go. So you're going to make a graph. We're going to do this with Excel, not to worry. It's not going to be hard with Excel, but there are a few choices that you need to make. So first thing first is we're going to decide what goes along each axis. So the x-axis along the bottom here, that is called the independent variable. And I'll explain what that means in just a minute if you're not sure. The y-axis is this vertical axis, and that is the dependent variable. So in terms of why we're like what goes where, the independent variable is usually the variable you use this, so use this to make predictions. And this is what we're going to predict. Predict, sorry about my handwriting, it's weird to write sideways. Predict this one. Okay. So it feels like we're almost setting up a causal relationship. We really aren't, but we want to make a prediction about that using this. Now, one last thing. So this usually comes first, and then usually comes second. Okay, I need to give examples because those don't even make sense, do they? Okay, so let's do the prediction thing first. So let's say that I want to predict your final exam based on your homework score. Let's say I wanted to predict your final exam score based on your homework score. What I could do is I could take this graph and I could make a prediction. Like let's say that someone here has a homework score of 60. Can I predict your final exam score? Well, I can. Whether or not it's true or not is another story, or how good the prediction is another story. But I think I would say that if someone had a 60 in here for their homework, I'm gonna go on a limb and say I would not be surprised if your final exam was around a 70. It kind of makes sense. It's right there in the middle of the data, right? So I'm using the homework score to predict the final exam score. So the other thing that I had, which after I wrote it, it didn't make a lot of sense to me, so I thought I should explain, is this idea of usually comes first and usually comes second. So temporally or in time, homework. So your homework grade you've been doing all semester. Final exam is at the end. So usually the thing that comes last is over here. Usually. And the thing that comes first is over here. So that's all that was supposed to mean. So you're usually using this tool to make predictions. So I want to predict someone's final exam score based on their homework grade. Or I want to predict what year do I think someone thinks that MLK was assassinated based on when they think that MLK died. Those sorts of things. I have other graphs here. Wait, where's another graph? Here's a graph. Yeah, test 2 and test 3. Test 2 and test 3. This was a semester where I gave exams out of 50 for some reason. I don't know, I was crazy back then. But you can see that, things, it looks like if someone took a shotgun and just shot. Actually, it looks like they started in the upper right corner and shot downward, but there is a trend, isn't there? There's a trend. And so we should be able to predict test 3 based upon test 2. So that's what I'm trying to get at here with this prediction thing. And what comes first, what comes second. So getting back to this, let's go back to our Excel spreadsheet here. The movies and the math. I'm going to say that the movies, we're going to try to predict someone's math score based on how many movies they watch per week. Kind of makes sense. We've done this experiment, and we want to know how dumb someone is or how smart they are based on how many movies they're watching each week. So here's how we're going to do this. Once you've got that figured out, oh, I need to go back here one more time. So the x-axis, whatever's there, has to be on the left. On the left when you're doing Excel. Oops, well, too late now. And the y-axis, that's going to go on the right when you're doing Excel. So left for the x-axis, right on the y-axis. So here, the one on the left is the movies. And so if you wanted to predict the movies based on the math score, you'd have to switch them. But this is already set up correctly. So here's how we're going to do this. Now that we've done this, I know you know how to make a scatter plot on a piece of paper from 7th grade. But here's how you make a scatter plot in Excel. You highlight, so see how I've highlighted all my data. Then you go up to the insert on the ribbon, this tab, insert. And then you see there's recommended charts, but I find that Excel has a hard time recommending good charts. And so I'll either go down here to the insert scatter, so that's one of the options, or if you don't have that, you can just click this little arrow down here, the recommended charts again, and then just select all charts and find your scatter plot. And you don't want that one, you want this one. So notice that they have two different scatter plots. This one assumes that you have two time series. You know, they're saying, okay, we'll just have, here's the movies, here's the math, here's movies, math. That's not the one we want. We want the one where the x-axis is the movies, the y-axis is the math score. So let's insert that. All done. There we go. Wasn't so hard, was it? Well, it really isn't too bad. What's going to be bad is when you have to do this on Newton and they ask you, I'll show you if we have time, to move these little dots around to be in the right position. It's really annoying. So sorry, I know I signed it, but it is annoying. Okay, next thing I want to mention is, once we'll go back to this, where is that graph that I showed you just a minute ago? There it is. So we could draw a line through the middle. Now there's some mathematics involved in this line, but I could draw a line, and that line is approximately, that's like the line that would be a pretty good fit. I think that we'd all agree that that red line is a better fit for these data than this blue line up here. Like, which one is better? Well, the red one is better. And the red one is also better than this green one. So the red one is probably the best line. Now, mathematically, we have a way of computing which one is the best line. And anytime you talk about the best thing mathematically, we've got to do calculus. We're not going to do calculus. I'll show you what. You're going to click something in just a minute to get that line. But Excel does a great job in finding that line. That red dotted line is the line that Excel finds. And it's the best line based on some parameters that, like we talk about, like the distance, how far dots are. So this is the one that minimizes the distance, the total, basically the total distance that these dots are away from the line. And to get that line, this so-called least squares regression line, when you've got your graph, all you have to do is right-click, or if you're a Macintosh, double touch, I don't know, whatever it is that you Mac people do. Right-click one of the dots. Wait, where's my mouse? It's here. Right-click. Come on. Well, that's weird. Why is it not doing anything? Oh, there it is. I was right-clicking the wrong dot, apparently. Okay, right-click one of the dots, and it says Add Trend Line. You might see it at the bottom there. It's pixelated, but it's there. You can always watch the video later and zoom in. And you've got all sorts of options. And some of you science people are like, hey, Logarithmic, we love logarithms in science, don't we? But, or exponential. So there's all sorts of different, we're just going to stick with linear. That's the only one that we hear about. And then also display the equation on the chart. Display the equation on the chart. We want to do that. So go ahead and click that and then click, oh wait, it's where to go. Why is the equation not there? So weird. Why? See, set intercept. Oh, there it is. I feel like this is, ooh, what just happened? Okay, I don't know what just happened. I think my Excel, something's going wrong. Yeah, something's not right. Normal, oh, just a minute. Can I undo format trend line? Set intercept. I don't know, something's wrong with my Excel. This shouldn't be like this. Yeah, I feel like I've got a problem. Trend line. Okay, that's better. Okay, finally, it's behaving. I can move that equation. That's what I wanted to do. I can move the equation. I can make it bigger. Look at it, make it huge so that everyone can see and enjoy. But that's the equation of that particular line. And it might be giving you bad memories of your algebra class, but you have y equals mx plus b. M negative, so you have this negative slope, plus that's the y-intercept over here. So we've got this equation that is going to be the equation for the trend line. Okay, so let's go take a look at Newton, because this is just about as far as I want to go. On Newton, you're going to have to do things like this. Notice that it says it wants you to come up with the trend line, this y equals mx plus b. So the way you do this, or the way that I've found is the most efficient, is copy your data. So I'm going to do this. I'm at Control C because I don't like using my mouse, but you could also right click. I can't see. Is it the top thing there? Does that say copy? Anyway, copy that and then go back to Excel, and we'll use those other tabs later on Wednesday or something. So here's the data from Newton, and then do exactly what we just did. We highlight this, you insert, if it'll work for me, insert a scatter plot, beautiful, right click one of the dots or double touch, whatever it is that you guys do on the Macs, and then insert your trend line, display the equation. I know lots of things to do. I'm just going to make this big so that we can all see it. There it is. Okay, it's humongous now, but we can all read it at least. And so that's the equation that I'm going to type into here. And be aware, though, as I tried this weekend, it always wants you to round. And if you don't round, even if you're right, you're going to be wrong. So so check it out. I rounded 1.40 and 3.66. So I got that one right. Okay, so we got that one right. There's another type of problem that's this one's not bad, but okay. So this one's not bad, but bear with me just for another minute because I want to show you the one that's annoying. So this one's not bad. This one they want you to graph. They want you to graph this line. So notice that when you graph this, you can use the y-intercept. Y-intercept is when you plug 0 in here, you get -10. So I'll do that. Let's pull this dot down to -10. And then pick another point. So pick x equals 10 maybe. When x equals 10, I have -10 plus 1.5 times 10, which is -10 plus 15. So that's 5. So when x equals 10, y equals 5. There we go. So this isn't bad either. There's one, though, that's annoying. So give me a minute here. Let's see if I can find it. Continue. Oh, instructor cheat, that one. There, you can do that. That's easy. Hold on a minute. This is the one. This is the annoying one. So it was impossible for me to disentangle all of these just because the way Newton's set up. So this is the one that is the most tedious. So just work. It'll be okay. I'll show you what we're supposed to do though. It says you've got all of these lines. I don't even care what the story says. But for example, line 6, there are 90% of customers are waiting. 32% of them are return customers. And so I need to put line 6 to be 90 and 32. So here's, you see that dot that I'm moving around? That's line 6. So I need this to be 90 and 32. And this becomes quite, I found it to be really tedious. There we go. And then I have to do the same thing for line 5. I'll just do line 5 and then I'll call it a day, but because you're sick of this too. There we go. There's line 5. You'll have to move around lines 4, line 1, and you get all your dots in the right positions wherever they're supposed to be, and then you'll click submit. So that's the one that's the most tedious. I wanted to at least show you that. But the rest of it is pretty straightforward for Wednesday. We're just working with lines and understanding the relationship between variables. So on Wednesday, though, we'll have more correlations, though, and one that's quite shocking. Well, I always found it shocking. So I think that's it. If you want to stick around and chat, please do. Otherwise, you can